Hello everybody, my name is Askar Khan, your math coach from Wisdom Outlined Coaching, helping you learn. Welcome to this channel. In this lesson, we will study about irrational numbers. What are irrational numbers and how are they different from rational numbers? How can irrational numbers be plotted on a number line? Let us dive into the lesson. We learnt in our previous lesson what are rational numbers. Remember, a rational number is any number that can be written in the form p over q, where p is an integer and q is an integer and q cannot be equal to 0. Such a number is called a rational number. For example, 5 over 2. 5 is an integer, 2 is an integer, and of course 2 is not equal to 0. Therefore, 5 over 2 is a rational number. Now, what is an irrational number? Irrational number is one that cannot be written in the form p over q, where p is an integer and q is. So, irrational number is a number that cannot be written in the form p over q, where p is an integer and q is an integer. For example, of irrational numbers, if I write square root 2 over 5, is square root 2 an integer? No. Is 5 an integer? Yes. But a rational number is one where the numerator and the denominator has to be an integer. An irrational number is where any one of them, numerator or denominator, if it is not an integer, it becomes an irrational number. Another example of an irrational number is square root 3. Another one is pi, and so on. So, there are infinitely many irrational numbers, and also there are infinitely many rational numbers. Now, let us see how to plot an irrational number on a number line. Let us locate root 2, which is an irrational number, on a number line. But before we even attempt to do this, we must first understand what is the Pythagoras Theorem, which you studied in your grade 7. Pythagoras Theorem. Let us understand what's a Pythagoras Theorem. You know, in any right triangle, you know what's a right triangle? Where one angle is 90 degrees. The side opposite to 90 degrees is called the hypotenuse. Let's label that side as C, and the other two legs as A and B. Then the Pythagoras theorem says that C squared will be always equal to A squared plus B squared. This is called the Pythagoras theorem. Now, let's apply one example. Suppose, let's take, if I have a right angle triangle and if the two sides of the triangle are 1 and 1, and let us find out the hypotenuse C. How will I apply the Pythagoras theorem? According to the Pythagoras theorem, C squared is equal to 1 squared plus 1 squared. C squared is equal to 1 plus 1. C squared is equal to 2. How will I remove the square upon the C? I will take square roots on both sides, so that the square root and the square cancels. I am left with C is equal to square root 2. So, I found out the value of C by applying the Pythagoras theorem. So, great. Now we understand what a Pythagoras theorem is and how to find the value of C. We can use this theorem to locate square root 2 on the number line. Let us now proceed. Let's draw the number line as we know. We know a number line has a 0 in the middle, and on the right hand side we have 1, 2, 3 and so on, and on the left hand side -1, -2, -3 and so on. Now, how to locate square root 2 on the number line? In order to do that, let us place a square of unit 1. All the sides of the square are 1 between 0 to 1. And let us find out what is the length of this diagonal. Let's label that. This is going to be 90 degrees. Now, is this a right angle triangle? It is. And if I know the two sides as 1 and 1, we found out that the hypotenuse is going to be square root 2. So, this length is going to be square root 2. Now, what you do is you take a compass. I am sure you know what a compass is. Put the needle of the compass over here, which is nothing but you are taking O as the center. Open your compass until your pencil meets at the length B. Keeping the needle at O, open your compass until your pencil reaches the point B, and then slowly draw the arc, and you will meet at this point approximately. So, this length is square root 2. So, thus you have located square root 2 on the number line. So, we learned what rational numbers are, and we also learned what irrational numbers are. Now, we will add one more additional step to our knowledge. Rational numbers and irrational numbers together form real numbers, and real numbers are represented by the letter R. So, real numbers consist of rational numbers as well as irrational numbers. Let's take some examples. A quick quiz. Example: 5/2. Is this a rational number or an irrational number? It is a rational number because 5 is an integer and 2 is an integer, and of course 2 is not equal to 0. Very good. Is square root 2 a rational number or an irrational number? It is an irrational number because square root 2 is not an integer. Now, another quick question. Is 5/2 a real number? Yes, it is. Is square root 2 a real number? It is. Because rational number or irrational number, they fall under the category of real numbers. Now think. Pause and think for a moment. On a number line, can I mark a rational number? Yes, of course, I can mark a rational number. For example, something like 5/2, which is 2.5, right? This is a rational number which can be marked. And we also saw that can I mark square root 2 on a rational number, on a number line? Yes, that means I can mark both rational numbers as well as irrational numbers on a number line. So, can I call this number line as a real number line also? Real number line? Yes. So a number line can also be called as a real number line because we can mark both rational numbers as well as irrational numbers on it. Great. Now let's see whether you have understood the concept by asking few quick questions. Let's try this. A quick quiz. State whether the following statements are true or false. Justify your answer. Every irrational number is a real number. Is it true or false? It's true. Correct. Now let's get to another one. Every point on the number line is of the form square root m, where m is a natural number. You know what a natural number is? Natural numbers 1, 2, 3, 4, 5 and so on. So the question is asking, every point on the number line is of the form square root m, true or false? It's false because you can't find the square root of a negative number. The square root of a negative number is not a natural number. So this statement is false. Every real number is an irrational number. True or false? It's false again because 5 over 2 is a real number. It is also a rational number. So every real number is not necessarily an irrational number. Real number can be rational as well as irrational. Great going. Let's look at this. Are the square roots of all positive integers irrational? If not, give an example of the square root of a number that is a rational number. This is pretty easy. Are the square roots of all positive integers irrational? No, they are not irrational. For example, square root 4. What is the square root of 4? It is 2. So this is a rational number. So square roots of all positive integers is not necessarily irrational. Thank you for watching this video. This completes our understanding of irrational numbers. If you have any doubts and you're looking for math coaching classes, you can contact me on WhatsApp by the number I have given in the front page of the screen. Thank you very much and wish you good luck for further understanding of math. Keep watching my videos as we proceed further and further and dive deeper and deeper into this curriculum. Thank you. Have a nice day.